1/2 and 3/5 are the first two terms of an arithmetic sequence. Find the fourth term. So this is the second term minus the first term is the common difference. So d is equals to 3/5, take away 1/2. We simply subtract by finding a common denominator, so we'll make it 10. The LCM of 5 and 2 is 10. So 5 times 2 is 10, so 3 times 2 is 6. 2 times 5 is 10, so 1 times 5 is 5. So the common difference d is 1/10. Now the formula we have is Tn is equals to T1 plus n minus 1d. We're trying to find the fourth term, so n is equals to 4. T1 is given as 1/2. N is 4. And d we found to be 1/10. So we have 1/2 plus 3 times this fraction, which is 3/10. We multiply top and bottom by 5, so we have 5/10 plus 3/10, which is 8/10, which can be reduced to 4/5. How many terms are in this sequence? This here is arithmetic because we're going down by 5, minus 5, minus 5, etc. Now the last term is negative 160. Recall the formula. Tn equals T1 plus n minus 1d. The last term is your Tn. So negative 160 equals T1, our first term, 45, plus n, which is what we're trying to solve, minus 1d. And the common difference is negative 5. So let's use some distribution. We're going to multiply here and here. Negative 5 times n is negative 5n, and negative 5 times negative 1 is positive 5. And we can throw the negative 160 to the right, leaving nothing left on the left. The negative 160 becomes positive 160 plus 45 is 205. We're going to throw the 5n over, and we now have positive 5n is equals to 205 plus 5 is 210. Now you could use a calculator, or you can double both parts. We know that 10n is equals to 420. So when we divide by 10, we now have n equals 42. So there are 42 terms in this sequence. The second term of an arithmetic sequence is 7. You may want to write T2 equals 7, which means is 7. This here is the second term. However, another way of writing this is we could say that T1 plus D equals 7. This here is the second term, because the second term is simply the first term plus one extra common difference d. So that's our first equation. Now the second part here is the 13th term is negative 37. We could write T13 equals negative 37. However, we can also write T1 plus 12D equals negative 37 directly and more efficiently, because the first term plus 12 extra jumps is this value. So now we have equation number 1 and equation number 2. And surprisingly in math, we are allowed to subtract equations, top minus bottom and bottom minus top. So let's perform some arithmetic. Let's subtract 2, take away 1, and see what happens. We have an equal sign here, and first we're going to subtract 12d, take away d, and the answer is 11d. If you have 12 dogs and you take away the top, which is a dog, you only have 11 dogs. T1, take away T1 disappears, it's 0 essentially. And we have negative 37, take away the top, which becomes more negative. It becomes negative 44. So now we have the combined intelligence of 2 minus 1. We divide both sides by 11, and we get d is equals to negative 4. So now that we have d is equals to negative 4, we simply substitute into either equation. We'll substitute into here, allowing us to solve for t1, which is what the question is asking for. So continuing, we have t1 plus d, which happens to be negative 4, is equals to 7. So t1 is equals to 7 plus 4, which is 11. And we found the first term of the sequence.